One and all. I would like to introduce Dr. Rajan Patel. Uh, Dr. Rajan Patel, he is professor in Computer Engineering Department of GIT, Gandhinagar Institute of Technology. He has done BE in Computer Engineering with distinction from Saurashtra University and MTech from NIT Surat and a PhD from RK University, Rajkot. He has 16 years experience of teaching experience in PG and UG. The area of interest is information security, computer networking, IoT with intelligent system, and data science. Right, and he received 4 grants for the research work, and he is awarded 10 awards for the in different conference for the best research paper. He has also so many memberships in different areas, association, and he also delivered as a resource person. So many lectures he has delivered as a resource person, and he has 45 plus publications in national and international conferences. So I would like to welcome Sir Dr. Rajan Patel. So, sir, welcome to FITCS, Faculty of IT and Computer Science.
Thank you, ma'am.
Now session is hand over to you.
Thank you, ma'am. And good afternoon, everyone. First of all, I'm thankful to Dr. Priya ma'am and Kamini madam, as well as Parul University for giving me such a platform to share my skill on IoT. So, friends, just a minute. Okay. Uh, so, friends, here I'm just sharing my screen, and I'll start my presentation. Right. So I hope all the participants, I mean all the listeners are based on computer background. So I'll assume the few of the things which are the known by you, especially in programming as well as the basic about the computing. So friends, in this session, part of the IoT, I'll discuss the Contiki and Koja. Contiki, it's one of the operating system. I mean, one of the famous and popular operating system for the IoT. And Koja, it is the simulator for the IoT. I mean, for IoT-based applications, it is frequently used in IoT-based applications for the research, especially Koja tool. So as we know, the current and future trends, that is nothing but the things, it's a IoT. So here, the word itself, IoT, that is Internet of Things, right? And during this session, I'll cover the basic about the IoT, that means IoT introduction. Then we'll briefly discuss the current and future trends, right, of IoT. After that, one of the operating system will discuss the features of this operating system, right? And then after, mainly we focus one of the inbuilt tool in this operating system, that is Koja. I mean, how to install it, how to use it, and demonstrations of the one of the popular protocol for the MQTT. I mean, for the IoT, that is MQTT. Right? We'll see in depth about the MQTT. So, IoT is also known as machine to machine, Internet of Everything, world size of web, Skynet, web of things, web of everything. So one concept, many name, right? So there are many alternative names for the IoT. So let's begin with a brief about, I mean, the definitions for the IoT. IoT is the interconnecting infrastructure of things and objects. So objects or things would be living or non-living. Living things, that means human, animals. Non-living, as we know, physical devices, vehicles, food, clothes, items, and many things, which are the embedded with. some electronics softwares with the help of softwares, sensors, or say actuators, and network connectivities with integrations of people, process, and technology that will enable these objects to be sensed or controlled remotely across infrastructure by collecting or exchanging the information. So simply, the Internet of Things is the network of physical objects, devices, vehicles, buildings, and other items which are the embedded with electronics, software, sensors, and network connectivity that will enable these objects to collect and exchange the information or say data, right? So this is the virtual world where all things are connected together. And just you just visualize or imagine the scenario, all things including living and non-living, everything are connected together, and right, and these virtual worlds, and that is the possible because of only IoT, right? So according to me, IoT is not a new technology, it is the extended of the embedded things. It is the extended of the embedded things or say embedded technology in which all things are connected together on the internet. And that's why due to IoT, as a technical people, we have wider scopes like in embedded technology, small range communication technologies such as wireless sensor network, mobile ad hoc network, hardware, especially sensors or smart device developments, distributed networks and data storage like cloud computing, analysis and visualizations of data or informations with the help of data science and scientific analysis, right? GUI developments, and of course, its security. Right? Here you can see one of the car is moving, right? So the sense information, I mean the motion, the speeds of the car, the positions of the car, that will be stored on the cloud with the help of communication technology, and later on that will be analyzed. So mainly, in IoT has mainly four layers: sensors or actuators, that is physical layers, then through network layers, all the logs, all the data that will be stored, and the data processing layer. And after that, after filtering or after applying this some scientific analysis or say big data analytics, at application layer, the user will be able to handle, control, monitor, or say view it. So my aim is here is to highlighting the current and future technologies which are the most demanding, such as smart sensors with the help of uh, AI, artificial intelligence, data, deep learning or machine learning, then after communication technologies in terms of 4G, 5G, Python programming, or say for IoT based application developments, we need programming language. So mainly most popular programming language, that is Python. Apart from that, obviously not only Python, the C++, Java, and .NET, right? Then cloud computing, that is used for data storage as well as for computing, analytics and filtering with the help of artificial intelligence, deep learning, or say machine learning, or say in data science or say big data analytics. Then interactive GUI developments, obviously security. Here not only cyber security, but now here the one word added, that is cyber physical security. Why physical? Because in IoT the all things are connected together. It means not only informations, we need not only to protect the informations, I mean digital assets, we need to also protect the things, I mean all things, all living, all non-living things in terms of physically, right? That's why this cyber physical security. So these are the fields which are the most demanding currently, which are the in most demand, right? So being a IoT developer or being a IoT engineer, we know we needs skills, that is about the sensors. I mean, what type of the sensors will you use in your applications, such as temperatures, humidity sensors, smoke sensors. That depends based on the applications. Right? Then controller. You heard many times Arduino, Raspberry Pi. These are the controllers. Right? In these controllers, already inbuilt operating systems are there, right? Here today in this sessions, we'll discuss about the one of the operating system that is most popular. According to the this source, the top 15 OS for IoT development. So one of them that is the Contiki operating system. So today we'll see in Contiki operating system how it will be used for IoT developments and how the simulator, I mean how the inbuilt simulator can be used for the IoT development. Right? Then we need communication, right? Where the our sensors, or say where the our physical things, or say the things which are the deploy, and we need to communicate, or communications among them required. So that's why the communication may be in small range communications, maybe a wider range communications, so in the form of MANET. Here MANET is there: mobile ad hoc network, wireless area networks, or say wireless sensor network, mesh network, Bluetooth networks, and global network. Obviously, there is internet, right? Programming language, that is Java, .NET, Python. Many of the people are right now, I mean, using the Python and C++ as well as Java. Then obviously we need a cloud computing, right? So for the data storage, I mean, where your data that will be stored centrally, right? Even though today's the cloud computing, I mean, cloud itself is not used only for data storage, it will also use for computing. I mean, we can also apply the some scientific analysis, computing processing, right? So based on that, at the end users, that means in our mobile phones, smartphones, or the smart devices, or the small screen device, that can be visible in the form of GUI, right? And here I'm not, I mean, here I'm not listed the few of the protocols like MQTT, COPE, and many of them are there. So the question is, current market trends. If you see, you know, the number of IoT devices, worldwide is forecast to almost triple, of from 8.74 billion in 2020, right? Two more 25 billion IoT device in 2030. That is just amazing, right? It means everything across the world, across us, everything is connected together. And just visualize what happened, right? So in 2020, the highest number of devices of IoT is found in China, that is with 3.17 billion devices. Right? So IoT devices are used in all type of industry verticals and consumers markets, with the consumer segments for around 60 percentage of all IoT connected devices in the 2020. Right? So the global market for IoT end user solution is expected to grow to 418 billion US dollar in size at the end of 2021, right? So forecast suggested that this figure will grow to around 1.6 trillion in 2025, right? And these are the companies, according to the IoT analytics database, where they did the survey, more than 2000 plus IoT based companies. The top 15 emerging IoT things cities, based on the company headquarters locations, are located in this figure, right? IoT will be massive driven or global economic growth, where Bangalore is the in the 10th position, right? So applications of IoT technologies are multiple because of its accessible to almost any technology that is capable of providing the relevant information about its own operation, about the performance of an activities, or even about the environmental conditions, and that we need to monitor and control at a distance. So nowadays, many companies from different sectors are adopting this technology. I mean, adopting this IoT technology to simplify, improve, automate, and control the different processes. So IoT applications, which are the listed, and many more are there that will be used for smart cities, smart healthcare, smart buildings, smart educations in parking, transportation, power supplies, automobiles, industries and automations, food and supplies chain, resource management, agricultural, waste management, water treatments, also water management, data centers, and many more. It means just visualize the world where all things are connected together, right? So the question is where it is, where IoT is. It is applicable everywhere. It is applicable everywhere. Right? Uh, I'll show you the video. Smart robotic kitchens where you can embed the things in IoT, right? With the kind of the hardware sensors, and they are connected to all together. And through your monitor screens, through your computer screen, through your mobile phones, you just operate it. You can give the commands, right? See here, he selected the kind of food, right? Based on the he or her appropriate uh, diets types, right? And accordingly, the device, I mean, this robot that will be make a food. This is one of them. Yeah, this is Dosa Maker. Earlier, it was only up to the a particular device, right? Here we have to operate this Dosa Maker through this switching, I mean, through this switch, right? Through these keypads. Right? Now, this maker is connected to our mobile phone, right? Through that phone, we can give the commands. Through that phone, we can select its right ingredients, whatever the requirements on the basis of that one. Right? And that's why the things all things are connected together. So earlier it was only for AC. We can operate the AC through phone, smartphone. Now we can operate not only AC, we can operate TV, AC, or other smart gadgets like the washing machine, or say all our electronics appliances through a single device, right? That is what we call smart home. See, this is what we call smart home. All things are connected to each other's. She receives all kind of the notifications in her mobile phone or in screen. see all appliances, including electronics or say all physical things, right, which are the connected together, so the people can be managed easily. So here in this video, it's showing the whole day activity, from early morning to late night, right? And remotely, it's notifying to the persons. I mean, notifying to the relevant person. Right now, she is in her office. Still, she receive a message, the rice or eggs, which are the out of stock, right? So she can manage it. She can order it. The lights will be automatically off if nobody in the particular hall or room. Right? So, friends, up to till now, discussion just was, I mean, just to motivate you about the IoT. Right? Now we'll see the one of the operating system, that is Contiki for IoT, and we'll see how to use one of them. I mean, one of the inbuilt simulators in this operating system, that is Koja, for the IoT based application development. Uh, Hello, may I audible?
Yes, sir. Yes, sir. You are
Okay,
audible.
okay, okay, fine. If anything, happened, then please let me know, because I'm just, you know, connected to
Sure,
share
sir.
to my
Sure.
professor.
Okay, sir. Sure.
Okay, fine, man. Okay, so Contiki, what is Contiki? It's a uh, just like a operating system. but it is a special operating system for IoT. As special, it is targeted small IoT devices with limited memory, power, bandwidth, and processing powers. Right? It used the minimalist design while still packing the common tools of modern operating systems like Microsoft Windows or Linux. Right? It provides functionality for management of processes, programs, resources, memory, and communications, same as other operating systems. It is open source. It means the license in which the copyright holder grants user the rights to use, study, change the distributed softwares and its source code for to anyone for any purpose. Right? And it was created by Adam Duckley in 2002. So, what are the characteristics of this operating system? So, obviously, one of the important characteristics that is hardware. I mean, a typical Contiki hardware has a memory on the order of kilobytes, a power budget on the order of milliwatts, right? Processing speeds measured in terms of megahertz, and communication bandwidth on the order of hundreds kilobits per second. Right? It means it support the constrained devices in terms of memory, low memory size, low processing or low power computing powers, right? As well as low communication bandwidth. Right? So such systems includes types of embedded systems or say old 8-bit computers. Right? Second, it supports standard protocols and it's enabled the recent other protocols for IoT developments such as micro IP. So Contiki provides three network mechanisms. One of them that is micro IP, right? Micro IP which provides IPv4 networking, right? The micro IPv6 which provides IPv6 networking, and one more that is RIME stack, which is a set of custom lightweight networking protocol designed for low power wireless network. Right? This RIM is an alternative network stack for use when the overhead of IPv4 or IPv6 stacks is prohibitive. The RIM stacks provides a set of communication primitives for low power wireless systems. The default primitives are single hop unicast, single hop broadcast, multi hop unicast, network flooding, and address free data collections. IPv6 text also contains the routing protocol for low power and lossy network, that is referred as RPL routing protocol for low power and lossy IPv6 network. It also supports constrained application protocol, COP, MQTT, and many other protocols. But these are the main networking, that is micro IP, micro IPv6, and DREAM, as well as RPLs and 6LoWPAN. Contiki systems are several power constraints. Not only these Contiki systems, but all IoT devices or the sensors normally are power constraints. So battery operated wireless sensors may need to provide years of unattended operations and with a little means to recharge or replace the batteries. Right? So Contiki provides a set of mechanisms to reduce the power consumptions of systems on which it runs, right? And in this Contiki, it uses the default mechanism that is available in operating system, that is referred as Contiki Mac. That these Contiki Mac nodes can be running in low power mode and still be able to receive and relay radio messages. Simulations. The Contiki system includes a sensor simulator called that is Cooja, right, which simulates of Contiki nodes or modes or actuators or sensors. This simulator will discuss later on with demonstrations. Then after programming models, to run efficiently on small memory systems, Contiki programming model is based on the photo threads. It is based on the photo threads. What is photo threads? It's a memory efficient programming abstraction that shares features of both multi-threading and event-driven programming to attain a low power memory overhead of the photo threads. So these photo threads, I mean multi-threading, we know what is multi-threading. That means multiple processes are running at a time, and that will be caused on an event on a particular conditions, right? The kernel that invokes in the photo threads in a particular process in response to an internal or external events. If I call internal events like timers that fires or message being posted to the other process, or external events like sensor that trigger or incoming packets from from received from a neighbor nodes, right? One more additional features available in this operating system, that is dynamic module loading. Dynamic module loading and linking at runtime supports environments in which application behavior changes after deployments. So Contiki module loader loads, relocates, and links the particular files. Apart from that, other features of Contiki, that is pre-process optional primitive multi-threading inter-process communications using message passing through events, as well as an optional GUI graphical user interface is also available with in two modes, either direct graphic supports for locally connected terminals, or it can be also supports network virtual, that is VNC, over the telnets for remote access. So friends, this is all about the Contiki operating system. Okay. Now we'll see Koja. Actually, I mean, you will see the simulating the IoT applications using this simulator. I mean, using this simulator Koja in Contiki OS, right? And this Koja is a Contiki network emulator. Actually, it's an emulator. It is not a simulator, but in general, we people, I mean, general people normally they call it is simulator, but being a technical people, we know it is a emulator. Simulator or emulator, both are the nothing but computerized program or say software for a specific purpose. Simulator is an, I mean, it's a kind of the environment in which models they behave or work accordingly, right? While emulator is one semi simulators, but that replicate the uses on the original system or devices. It means emulator can act in a real life and with real traffic too, right? While simulator, it's a kind, for example, if I call simulator that flight simulator, that means that gives you feeling of flying an airplane, but are connect completely disconnected from the actual or say reality of the flying the plane, right? And you can bend or you can break these rules, right? That is simulator. But in emulator, what happened? It act in a real traffic in real life, right? And the Koja, it's a emulator, and this simulator, that means Koja is an extensible Java based simulator that was developed in Java, right? That capable of emulating the various kind of the modes or sensors or actuators. I mean, these are the nodes, right? The code to be executed by the nodes is the exact same firmware you may upload to physically nodes. For example, our temperature sensors or the temperature sensor. This is what I call modes. So what I can do, I can do the programming. I can upload. I can load this code, executable code, in these temperature sensors in the firmware of the temperature sensors, right? So it allows a large and small networks of modes to be simulated, right? Koja is highly useful tool for Contiki development. it allows to the developers to test their app codes or applications or systems before running it on a targeted hardware, right? So developers regularly set up new simulators, simulations with the help of this Koja simulator to debug their softwares, to verify the behavior of the systems or say or applications or say sensors, right? And the GUI, I mean Koja itself, it's a GUI mode, right? So you will first need to visit. I mean, here I'll show you how to install it. So installations, it's a simply we have to use it. I mean, we have to first of all download the Contiki software. I mean, instant Contiki image from the websites, right? From these websites, the entire code image is available, right? So download it. Once the instance Contiki image has been downloaded, and then after unzip it and then open it with the help of VMware, virtual machine, right? So once I load it, uh, let me show you. So one of the VMware which is already preloaded in my system, right? I also downloaded the image, right? Now that is I call Contiki operating systems, right? So I start the system. In, Madam, okay. So the instant config is an Ubuntu based operating system, right, with Koja already built in and ready to use, right? So here the default password, that is user. So here this is my config operating system, right? Ultimately it's a based on the one of the customized Ubuntu based operating system, right? Okay. Now I want to open the Koja. Koja, it's a simulator, right? I want to open it, which is preloaded in this operating system. So open the command prompt and type a command, that is ant run. That is the command to run the Java-based applications. So first of all, I'll go to that directory Contiki, then tools. Now one of tools, that is Koja, this one, right? So again, I goes to that more for the Koja. Now I'll write the command, that is and run. So my Koja will be loaded. The Koja software should now start. Right? The resulting screen that will be displayed. Wait a minute. So although Koja can be extremely complex, by following few simple instructions, very quickly data can be collected from modes, as well as we can compile it, right? As giving you the ability to observe radio communications, message communications, outputs from modes within the particular networks, and to alter the transmissions as well as interference range of the particular modes that we'll see, right? So these are the benefits available, facilities or the features available in Koja. So this is the tools which is loaded, right? Now, after that, I have to click on that simulations. So creating a new simulations in this file, in file menu, you can start a new simulations, right? or we can also save the simulation, I mean simulated environments, right? So here, this moment will start a new one. So new simulations, then give it name of that new simulations. For example, say hello world, hello, right? Create it. So this is the screen, So the pop-up window that shows one, that is network simulation control, second one, third one, this is nodes, fourth one, mode outputs, and the fifth one, that is timeline. So what is network? I mean, these are the small tabs or so windows. It shows these windows that shows the location of each node in the network, right? These are the options available. Here it shows the locations of nodes or the deploy nodes. It can be used to visualize the status of each node, right? Including itself, its LED on or off, its ID, I mean node ID or say mode ID, then its address, right? So initially this window is empty, right? And when need to populate, it will our sensors, right? For example, okay, let me add, okay, I'll add it later on. So it should be noted that these options are based utilize selectively, as the window can be cluttered with too many options selected. These are the options, mode ID, address, IP base or say rim base, rim stakes base, outputs, LEDs, light emitting diodes of particular sensors or say nodes, radio range, position, background grid, mode type, right? Modes attributes and radio environments, right? Second window, that is a simulation control. Here you can see start, pause, step and reload. This panel is used to start, pause or reload or execute these steps of the simulation, right? It shows the time of executions and the speed of the simulation, right? Here it means that we can run the event several times faster than it would take in real life time execution. Right? Not the third window, that is it's simple notepad for taking any notes here, right? You can mention it, right? Then mode outputs. Here mode output, that means sensors, actuators, output nodes, right? It shows all outputs of serial interface of these mode nodes, right? Here in this window. Time, mode, name, ID, and the message, the conveyed action, the message, right? It is possible to enable one window of mode output for each node in a simulations, right? And then after here, this window, there is a timeline, right? This simulation timeline where messages and events such as channel changes, LEDs change, log outputs, etc. are shown here, right? You can even those save it also, right? So in addition to this, in addition to this default tools, I mean these five tools: network, simulation control, notepad, mode output and timeline, right? It is also possible to exhibit other tools such as breakpoints, radio message, a script editor, buffer view, and mode duty cycles, which can be enabled in IoT tools menu, right? But I'm not going in depth, right? Now here I'll demonstrate you key. Obviously, the first hello, one modes, one I'll deploy one sensor or say node or say mode, and that will be sense the particular, I mean display message. Say it broadcast the message hello hello like that one, right? So you need to create a new modes. Here simulation is created. Now how to create the new modes? So I have to click on the modes, add modes, create new modes. These are the supported listed types of the modes: sky modes, JAD modes, ESB modes, and many more modes are there. So normally, frequently, we are using the sky modes, right? Now here you have to give the name of that sensor or say actuator or say mode. Suppose here I'll give the name of that sensor, say hello, right? Now you have to load your firmware, you have to load your program, you have to load the codes. Here it is already there, hello world. Okay, let me see in these operating systems. Many inbuilt examples are also given to you. Right, you can use it. One of them, that is hello world, displaying the hello world. So select its hello world dot c file, right, which is in the C programming. Right, now then after click on open. Now what I have to do, I have to compile this file. Right, so click on this compile. Hmm. So here descriptions, the you can write the descriptions. Here we already given the description, that is hello, right, that is the name of mode. Right, hello mode 1 say, or say, okay, hello mode 1, right. Here code is completely compiled, right. Now I have to click on the create, right. So first mode type, and you can select the firmware. So here select this hello, right, to display the hello world. Right. So in this example, we'll use the hello world firmware, typically located at this position. Here I am using the currently Contiki version 3.0. Right. Now click on create. Okay, now it asking how many such kind of the nodes you may want to create. Suppose right now I want to create only one single. So one, right, so you can define the positions, and later on you can change it also. Once I click on add modes, right, here see this is the mode, and I can change the position also through my mouse. Now here we can use the various options available in this network window. There is mode id, see this one, mode id is applicable here. Let's see this one. Now sky modes, firmware loaded, that is hello world.c file. Right, address, then LEDs, it's showing there are three LEDs, red, blue, and green. Radio traffic, backgrounds, I mean, mode type, right, mode attributes, radio environment. So this is the range of these modes. It's a wireless modes. It can be communicated in this range only, right? So this is the way we can add the modes, right? After adding the modes, after successfully we add the modes, after successfully we compile the, you know, the firmware of this mode, that is hello world.c, hello world.c, right? Now I can start this simulation. Right? Right? So click on the starts. Once I click on the start button, and now I pause it, you just see in mode output. This is the output of these mode only, right? So here we have only one mode. So ID is 1111 is there. The particular time events, it's showing, RIM started, that is protocol stack started, network protocol started, MAC address, this is the MAC, right? CSMA, it uses the CSMA collision sense multiple access, right? Here it started send the hello world process, right? So hello world, hello world, hello world, like that way. Right? So this is the way. Now I'll again start it. Right? Here in this timeline, it's displaying here. This is the radio range of this particular mode. I'll pause it. Right? The same scenario you can reload also, right? After completing, right, what we do after our completion, suppose instead of this one modes or say nodes, we have many modes. We already simulated this all entire environments. Now after that, what we can do, we can save these simulation environments, right? So that can be later on, it can be reused, right? So here it is also one of that facility available in this simulator, right? Okay, fine. So this is all about Koja, right? So how to load it, this simulator, right? This is the pop-up window of this tool, and these are the window. I mean, these are the my main five default windows. As I already mentioned, the network window, simulation control, nodes, mode outputs, timeline, right? Now we already simulated the hello word. Now we'll see one more. That is, on or off the LEDs. Right? I'll show you. Then after, I'll quickly switch over to the MQTT. Right? So what I do, I'll close these simulations. For example, not exit, close. I don't want to save it, so remove it. Right? Now click on new simulations. Now here the new simulations, that is what I call LEDs, right? I mean LED on or off. So create it. Okay. Now what do we need to do? We need to add the obviously the modes. So mode here, create sky mode, right? Browse it, load the firmware. Uh, so in these examples, you see, yeah, here one of file, one of the C file is there, that is blink hello.c. Just see. Okay, click on open it. Now before to that, I would like to show you the code of this file. uh, I'll minimize it, play home folder, the Contiki examples. For example, hello, right? So here you can see this is the files. Open it, just see. This is a simple C files, right? Where you can write it. And as I already mentioned, it is a proto threads. It's an abstract level. Simply you have to include the a particular process, call the functions, call the process. Right? All right. Okay. Now here I'll add it. Okay, blink.c. Okay, added it. Now we have to compile it. Click on compile. It compiles. Output file is generated. Create. I want to create one modes. Okay. Now file. Grid, then okay, mode id is also important. IDs, okay, this is one showing me range also, right? This is, now I'll start the simulations. You can here see what is showing. This is the current status of LED. Okay, let me click on that options. LEDs, I think. Okay, let me zoom in so it will be more clear. Hope it is visible. Right now again, I just start that simulations for that particular. You can see the switching, the LED blinks, LED starts on off, on off, on off, on off, on off, right? So here it's showing the a particular LED status including the color code, red, green. I'll stop, pause. So current status is green, sorry, blue LED is on. So this is all about Koja, how to use it in Contiki operating systems, right? Now, main, that is MQTT, right? So MQTT is a client server publish or subscribe messaging transport protocol. It stands for Message Queuing Telemetry Transport Protocol. Right? It is designed as to be easy to implement, easy to use, and with the help of these characteristics, it makes it deals for use in many situations, including constrained environments such as for communications in machine to machine, in Internet of Things context where a small code footprints it's required, right? And network bandwidth is also constrained. Right? Although this MQTT, MQTT started as a proprietary protocol used to communicate with supervisory control and data acquisition, that is referred as SCADA systems, right, in the oil and gas industry earlier. But today it has become a popular in smart device, right? And today it is the leading open source protocol for connecting Internet of Things and Internet of all devices in IoT industries, right? So MQTT is the one of the most commonly used protocol in IoT projects, right? It's in addition, it is designed as lightweight message queuing protocol, that use publish and subscribe operation to exchange data between the client and server, right? Furthermore, it is a small size, low power uses, minimize data packets, right, and easy of implementation, make the protocol ideal for the machine to machine or say IoT world, right? So the question is why MQTT? So that is it has unique features. That is it is in a lightweight protocol, right? So it is easy to implement in a software and fast in a data transmission. It is based on messaging techniques, right? Uh, so of course you know how fast your message and WhatsApp message deliveries. Likewise, MQTT also work, right? Minimize data packets, right? And low network uses, low power uses. As a result, it saves the connected devices battery, right? It is real time, right? That's why it is specifically what makes it perfect for the IoT applications. Real time, a quick response, right? It's a real time protocol, right? So suppose one of the sensor publish a temperature, say at time t1, so immediately it will be receive all the subscribers, with the small, that means quick response, and in terms of at t1 time publish, at the same time with minor negligible delay, all the subscriber will receive it, right? So we see how it works. So this protocol, MQTT protocols, that's it's like any other internet protocol, right? It's a communication protocols, right? So MQTT is based on client server. So client machine is there, server is there. Likewise, the server, we know what is server. Server is one of the guy who is responsible for handling the client's requests, right? For receiving or sending the data between each others, right? So MQTT server is called a broker, right? Here MQTT server, that what it called a broker, and the clients are simply connected to the devices. The clients which are the connected to the devices, right? When a device, a client want to send data to a broker, right? We call it operation of publish. We call it operation as a publish. So it publish the information. The broker later on, the device wants to receive a data. This device, this client wants to receive a data, right, from the broker. So we call this operation as a subscribe, right? So they subscribe. In addition, the clients are publishing, right? So clients will publish through server. Server will be published to these subscribe nodes, right? What it publish the particular topics. Here the topics say temperature, right? So it will publish the temperature, available temperature at this particular place or say environment. It will be published to these clients or say nodes via MQTT broker. Okay? Let's an example. There is a device that has a temperature sensor. This is a one device that is a temperature sensor. Certainly it wants to send his regarding, reading to the broker. So this is server which is this temperature sensor simply publish its periodic, after every periodical time it's publish the information to this broker, right? On other side, a phone or a desktop, right, application wants to receive this temperature, wants to receive this temperature value. Therefore, two things will happen. The device define the topic it wants to publish, for example a temperature, right? Then it publish the message temperature value 21.3, right? The phone and also desktop applications, these subscribers, i mean uh, to the topic that is temperature, right? Then it receives the message that is device has published, right? And these subscribers that will receive the message that is which is the value of temperature, right? So again here is the broker role here is to take the message temperature value and deliver it to the subscribers, right? So main components for MQTTs are five. One, that is broker, which is the server, which is called MQTT server or the broker that handles the data transmission between the clients, right? Then topic, which is the place a device want to put or retrieve the message to or from, right? The message, which is the data that a device receive when subscribing for a particular topic or sent when the publishing to a topic. So publish, it is the process a device does to send its message to the broker or subscriber, where the device does to retrieve a message from the broker. It means publish, it's a device publisher that send a message to broker. Subscriber, these are the also device which receive a message from the broker. Right? What they will receive? They will receive a topic. Topic, that means a message, say temperature, for example. Right? And in that message, it has a value, right? Data value, right? So these are the main five components for MQTT protocol. So at this stage, I hope MQTT how it works. Basically, that is clear, right? So we'll simulate, right? Simulations for these MQTT protocols in our Koja, right? So I close this one, not exit, but close simulation. Okay. New simulations. My new simulation, that is MQTT. Fine. Create. After that, okay. As we know, in MQTT, mainly one publisher, one node, that is subscriber, right? Or many more than two or more nodes are part of the subscribers. There are many publishers. Ultimately, we need a publisher, subscribers, and a server, right? So main three nodes are required. So I'll create one of them, that is MQTT server. At the modes, so these modes act as a MQTT server. So as we know, server, that is what we call a broker or server. Mm, yes, right. Okay, I'll add it. Right. Border router, RPL. Contiki. Examples, IPv6. IPv6. Here we use the IPv6 for network communications, and we add the border router, and this one as a server, that is border router, right? So this node act as a server. Open it, I mean firmware is loaded, compile it. Oh, good. Compile. Now create what I call MQTT broker. Add mode. Oh, same name is there. Broker. Wait, what happened? Mode. MQTT broker. Add mode. Okay, say modes, new mode, say one. Okay, and mode ID, that is one. It's our MQTT broker or server. Now IP address visible, then LED is not required here, background, okay, and radio range. Okay. After that, I have to add MQTT publisher or say subscribers. That one. I'll write MQTT, for example, publisher, PUB, right? Browse, MQTT, main core, right? Load it, compile it, okay. Time. Now compile it, create, set. Oh, here we want to create one number nodes, add mode. Just see here. This is broker, that is server MQTT, and this is one of the, for example, say publisher, right? So I'll put it in the range of this server. Okay. So we added two modes, that is MQTT broker or say server, MQTT publishers. Now I'll add one more mode, that is subscriber. Sky mode, sorry, cancel. MQTT subscriber. The MQTT Contiki. This is the MQTT. This protocol, as I already mentioned, it is the open source. Right? It's available where you can download it, where you can reuse it. Right? So here I've already downloaded it. Now I'm using it. Right? Open it, compile it, create one. I mean, we want to create one more modes. Add. So this is the MQTT server or broker. This is the MQTT publisher, right? Now I'll put it in somewhere here. Now you just note it down. Third number, three number label node, it is called subscriber, which is not in the range of server. Then I mean, which is not, it is not range of the MQTT broker. Then also it will receive the published message. Right? See, okay. After adding, how to do some changes. This is the server. So in server, right click of these modes, additional options is available. Socket. I want to connect this server to the Koja tool. You just see this window is here, right? To this default port ID. But before to start it, I have to write uh, terminal cd Contiki examples IPv6, then our PL border router, and border router, right? Now I have to write one more command, that is make. I want to connect these two module to the Koja, right? Where the particular server that can be act as a server, as a act can be act as a MQTT server. So make file connect router. This is the command. where to connect router to the Koja, right? Okay. Now before it, or to start it, listen mode, and then after here I'll enter it. Now it's okay. User. Okay. Now this server is connected to this Koja tool, right? Where we can listen the all events. Fine. Now how to open the one more terminal, that is for MQTT cd Contiki MQTT cd tool, then Mosquito. You am using this Mosquito MQTT. One of the organizations who develop these MQTT modules in C program, which is open source. The source. Okay. Okay. Now clear. I'll write the one commands, that is make, compile it. Oh, okay, sorry. It. Okay, now it's perfectly compiled. I mean, the output file, that is broker underscore MQTT is created. Right now, I'll execute it. Uh, slash broker broker underscore. Oh, my keypad underscore is not working. Just a minute. Okay, I'll copy it. This one underscore, not here it is. Okay, I'll copy it. Okay, now paste, right? MQTT config MQTT. Start. Okay, it's listening on port number 1883, and the second one, that is 1884. Right? So already started. Now I have to switch to the simulations. Okay. Now here it is also server started. Both are also working. Now I'll start the simulations. Just see the modes outputs. Uh, Let me pause. Where is the arrow? Is not needs position already added. Pause it. Position. And it is not required. So just see here. This is the mode output. initially from where mode ID one, that is our server, right? Working. Let's see. After that, second, third number, that is subscriber. This is the subscriber, right? Just say.
I'm sorry to interrupt you, sir.
Not two
We
minutes
need to
only. Continue for 2 minutes.
conclude the session within 2 to 3 minutes.
It is already over. So here you
Okay,
just see
okay, sir.
the third number node is sending, I mean receiving the message that is hello, which is already published by the second number. It's via broker. Even though you can notify this broker, it is not in a range of subscribers. Then also subscriber is receiving the message. Right? Stop. Okay, fine. So this is all about the MQTT, right? The message queuing telemetry transfer protocol, right? So that is one of the real-time protocol which is widely used, especially in medical healthcare systems, right? Which is there are many subscribers. Subscriber in the form of doctors. They are the subscribers of their patients. The patients uh, wear the smart belts, so bells automatically notifying every periodically times, or say every after some periodic time, say every 1 hour or say 2 hours. That depends on the types of the patients, and it will be publish the heartbeats or say BP, blood pressures, or say any other medical related information, right? And then later on that can be utilized by the doctor. So this is all about the Koja, right? And these are the references I use, right, in order to demonstrate the Koja as well as Contiki operating systems. So if any query, any questions, then please ask me. I will be happy
Uh,
to take
yes,
all
sir.
your queries.
Uh, Thank you, sir. From our BCA and MCA students, we have 2 3 questions. First question is actually they are most of the students are doing the project in Android and with the sensors and Android. So one students have questions how we can connect Arduino code to the cloud database. uh, he want to connect the Arduino code to the cloud database. So how he can connect?
Yes. See, to connect, see, there are many inbuilt nowadays, even though many limited space, I mean, size, cloud spaces are available. So, simply what you have to do, you have to download a particular cloud API, right? And then that API you have to integrate in your programming, in your Android programming. So, through after integrating the that API in your Android, once you execute it, once you simulate it, that will be automatically will be stored the data on a cloud, right? Actually it's not a kind of a simple what we call key, within a half or 10 minutes you can do it, right? In that case you need Android, I mean cloud APIs, and there are lots of many APIs available, even though some of the APIs also are freely available, right, where you can connect to the cloud.
Okay, sir. Sir, next question is how to pass sensor data in Android application.
See, sensors, normally sensors are two types of the sensors. I mean, actually, I can say there are three types of sensors: active sensors, passive sensors, and semi-active sensors, right? So if it's a passive sensors, then simply it will be sense the data, right? After sensing the data, right, what it do? It's a connected to the particular controller, say Raspberry Pi or say Arduino, right? Through that controller, it will sense the information. For example, the temperature sensors that will be send it, right? It's sent to the controller. Controller it's nothing but it is already connected to the our local area networks, or through a border gateway it is connected to the cloud, right? So one sensor will notify the event, once the sensor will sense the events or say publish the data or information that will be passed through the controller through via communication to the cloud or maybe at a local place. After filtering it will be forwarded to the particular cloud. Let me show you time permit, then let me show the demo for that one. It will be more clear. Just a minute, just a minute. साहब પછી વાત करो ओए ओए हाँ see here, right? Suppose this is a humidity, I mean it's a temperature in a transportation, right? A box is there, box is nothing but full of fruits, right? Where the sensors are loaded. So sensors measuring the temperatures or humidities or say any types, that will be so in these sensors already controller is there, so through controller it's broadcasting or say it communicating the information say in a Google Cloud, right? And then after through programming the data which is already logged on a cloud we can access, right, on a GUI or an application layer, right? If you time permit then I'll show the demo also for this one.
Okay, sir. Okay, sir. Thank you, sir. Thank you so much for sharing your time, sharing your
Ma'am,
valuable
if you
knowledge
give
with
me,
us.
sorry
Yes,
for interrupting you, ma'am, but
yes,
if you
sir.
give me only 2 minutes, 2 more minutes, then I'll show the demonstrations of this one. That will
Okay,
be
sir.
more clear.
Okay, sir. Our students are interested. Okay, sir.
I'm running out of time, but sorry for that one.
Actually, our MCA students have done the projects, last semester
Okay,
students.
okay,
Uh,
final year students. Yeah.
Final students. They are doing the projects, Android applications with IoT. So they are interested in this. So these questions from that is
No, no, ma'am, it's a
MCA.
good one. Right. Actually, here I demonstrate the Koja, na, that is mainly used for the